So hope y'all are ready to learn about the ocean tides. Anybody know anything about ocean tides? No? How you guys handling this quarantine stuff? Do you not talk to anybody anymore? You just text everything now? You just wave on your video?
Grenade, I'm going to be completely honest. Quarantine is great.
No, I think you guys are going to enjoy this way too much. You get to sleep in, go to class for 20, 30 minutes. I'm assuming calculus class and pre-calculus class are longer.
We've already
It's
learned
not bad. I just woke up like 40 minutes ago.
You woke up 40 minutes ago. That's great.
Yeah.
How's calculus page?
Well, for Calc 2, they cut out a bunch of topics, so we've already learned everything that we have to know. So we're just doing like practice stuff.
So it's pretty short. All right.
Yeah. It's
Well,
not bad.
if anybody, I don't think Natalie has joined us. I think she's the only one who's had problems getting on. So if anybody happens to talk to her or wants to text her and help her figure it out by next week, that'd be awesome. So just
She was just trying to get on a second ago.
she was.
Yeah, she texted me to see what the code was. And so I think she's trying to figure it out right now.
All right. Well, hopefully she'll get on because I think. Oh, she might have made it. I don't know. Okay. So, we should be able to finish up chapter 9. Oh, probably by Wednesday, Tuesday or Wednesday of next week, and then we'll go into chapter 10 and go from there. So, again, at the end of class today, we will open it up for questions on yesterday's assignments, either the last 2 days' assignments, and kind of go from there. All right. So let's get started with ocean tides. As I mentioned yesterday a little bit, because we're talking this whole chapter is about gravity. Ocean tides, in a simple sense, are caused by the moon. And you're like, well, how does that happen? Well, first of all, it should be noted that it wasn't easy to come up with because that was one of the things. Like, obviously, people knew there were tides, right? If you hang out the ocean for more than an hour, you realize that the water level changes, and so there's a lot of theories. But the biggest problem for explaining tides is why is there two high tides and why is there two low tides every day? And so, that's kind of a consideration. Newton, of course, should not be a surprise, was the one who came up with the explanation. Ocean tides, and this is probably the main point, ocean tides are caused by differences in the gravitational pull between the moon and the earth. Okay? Ocean tides are caused by the differences in the gravitational pull between the moon and the earth. Okay? So let me kind of try to explain that a little bit. Okay? I hope you can tell which one is the earth and which one is the moon. I hope that it's obvious that at a point on this side of the earth, it is going to feel a much larger force of gravity between the earth and the moon than something on this side. Why? Because the distance is quite a bit different, right? This distance is a lot closer than that distance. Okay? And according to our formula for force, when we square that distance, it becomes a significant difference in the gravitational force between the Earth and the Moon. Now, this is obviously a simplified version. The Moon is not really that close to us, but that's still kind of the way it is. Okay, so what happens, let me draw a different picture. What happens is that this is again a kind of over exaggeration. But if the moon is here, what happens is if this is the original shape of the Earth, it pulls like an eyeball.
I cannot see the picture at all. Like my screen is just
Yeah,
blinking
like-
the whole time.
Nobody
I
is seeing
can't see
it?
anything that you're doing.
No.
How's that?
Mm-mm.
No, you got
Still nothing.
Well, that's weird. Let me try this. How about there?
Oh,
Nope.
better keep moving it over.
Hold on. How about now?
I see it. Yes, I see it now.
Now?
Do you guys see that green line?
Yeah, I see the. Well, now it's gone. I saw the like
Green line.
black ovals and then the green squiggly.
Okay. So let me try that. Let me try that again. Hey, you guys are not to be drawing on here. Okay. So can you guys see this now? If I draw this?
Yes.
I
Wait,
saw a
the
smiley
smiley
face.
face or the circle?
Circle.
Okay, I see the circle.
Okay. So this is the moon. Okay. This is the Earth, obviously. So this is gonna be a exaggerated view, but what happens is that the gravitational force from the Earth and Moon pull the Earth into kind of an oblong, almost like a lemon shape. Okay. And so if there is any, let's see, how do I want to explain this? If there's any oceans over on this side, okay, then those waters are going to want to go in that direction. Now you might think, well, what, obviously there's a pull here, right? So why does it become oval shaped in this? Remember that something playing piano, they got to mute their. You guys got to mute your screen. I'm gonna mute you. Hold on. All right. We're good now. Okay, where was I? So why is this side over here also kind of an oblong shape? Well, anything that's in a centripetal force and centripetal motion is going to be round. Well, when the moon pulls this side of the Earth into a not round shape, this side, the back side over here, has to be pulled in the same or in the opposite direction in order to keep equilibrium. Okay, you can't just have one part of the Earth that is misshapen without the other side balancing it out because it's moving in a circular motion. Okay, so because of that, you have waters on this side going towards the moon, but any waters on this side are also going to go in that direction because that's the way it's pulled. Okay, now I'm going to attempt to show you that. I have a little demonstration here at my house, and so we're going to try this and see how it works. So hold on a second. Okay, so you can see my little bowl of water here. Okay, now I don't know if you can see right there. See that blue piece of tape? Okay, so that's a nice, perfectly round water in that bowl. Okay.
Mr. Granillo, we can't.
You can't see it?
At least I can't.
Okay, hold on.
There we go.
Can you see it now?
Yeah.
Okay. And you can see the blue tape? Okay, good. All right, so now I have, oh, this is going to be hard to do with one hand. Okay. If I pull on this handle over here, okay, this is all backwards to me. I'm trying to show you the, here, let's go this way. Nope, that's not going to work. Time out. Boy, if you thought experiments were tough in the classroom, they're getting real tough now. All right, hold on. I'm going to pause something. I got to get some help. I got to get some hands. So hold on. Be right there. Okay. I need you to hold this so that you can videotape the bowl and the blue line. Okay?
Wait, what blue? Oh,
See that blue line right there?
the tape. Yes.
Yeah. Make sure that's in the
Yeah.
screen. It's opposite of what you think.
That's stupid. Wait. Oh my gosh.
Okay. So if I pull on the bowl, I'm going to change its shape. I want you to, I don't know if you're going to be able to see this or not. Avery, can you zoom? This is Avery trying to help me, by the way. Avery, can you actually get closer to that blue line? Yeah. Go closer.
Why is this
Closer.
opposite? Why is this opposite?
Closer. This is a college student having problems with technology.
It's opposite.
Okay, hold it right there. Got it? Okay, can you see the blue line close to the blue tape? Okay, now when I pull this, I'm going to pull this in the direction of the tape. Watch the water line get closer. See how it gets closer to the tape? Now it's over the top of the tape. Can you guys see that at all? I don't know if you can see that, but I'm pulling.
Kind of.
Draw back now, Avery, so they can see. So I'm making the bowl kind of oval, right? And that's basically what the moon is doing to the Earth, is it's pulling the water so it raises on the long sides and gets shorter on the other. Okay, so you can try that at home if you really like. I can try to take a better video of it
We good?
later. We're good. Okay, so we should be back onto the whiteboard now. Okay, so anywhere there's an ocean, I'm going to try to draw a simplified view. There we go. Okay, so let's say that this is the United States and this is Europe, okay? The Atlantic Ocean. In between, right? So if Europe is the side of the Earth that's closest to the moon, then the water is going to be pulled because the Earth is the shape of the Earth is going in that direction. The water is going to be pulled that way, and we're going to have a high tide over here, and guess what? A low tide over here because the United States is farther away from the moon, right? The moon would be over on this side, okay? So we get a high tide. Time out. Okay, so now that happens. Anybody have any idea how many times or how often the moon goes around the Earth? 24 hours. Actually, it takes 24 hours. 50 minutes for the moon to revolve around for the moon to revolve around the Earth. Okay, so now we're going to look at a different we're going to look at a different view. Okay, so when the moon is over here, we're going to have a high tide here, and we're going to have high tides over here. Okay, as the moon revolves 6 hours later, right? Oh, okay. Then those high tides change right? So now the moon's over here. The moon's over here now, and we have a high tide here and a high tide here and low tides on these sides. Okay. As the moon continues rotating around the earth and it's over on this side now, again, we get a high tide here and a high tide over here again. Okay, so that's why within this 24-hour cycle, as the moon's going around, we get two times during the day, we get a high tide, and 2 times during the day, we get a low tide. So if the moon is here or here, you get a high tide on both sides of the earth. And when the moon is here and here, you get high tides on those 2 sides and low tides on the other parts of the earth. Okay? So again, this is a quote unquote a simplified view of the tides, but this is basically what's happening. Okay? One thing to keep in mind is that this is happening because the difference in the gravitational force here is a lot different than it is over here. Okay? Now, a couple of other notes. The average high tide is 1 meter above normal. So if the ocean was completely flat, a high tide would be 1 meter above that, basically about 3 feet. And a low tide then would be 1 meter below that, right? Now, there are a lot of other factors, some other factors like the landscape or the ocean floor and some other things that affect tides. And we'll talk about that in a little bit. But on average, a high tide is about 3 meters. Okay? I'm sorry, 1 meter, 3 feet. Now, when are tides the highest? Okay, you can go ahead and unmute if you like. If you want to try to guess when tides would be the highest. What time of the year or what time of the month would tides be the highest? Nobody has any ideas? Okay. So think about this. Let me draw this back here a little farther. Okay. A high tide happens when the moon is as it's moving across, right? Every time that we can get, let's see, how do I want to say it? The moon, whenever the moon is closest in its orbit, how about if we just say it that way? When the moon is closest in its orbit around the Earth, remember that the moon does not go around the Earth in a perfect circle, right? It goes around in an elliptical path. And so 2 times in the day, it's going to be closest to the Earth, and 2 times in the day, it's going to be farther away. And those 2 times when it's closest are when we're going to have high tides and stuff. But we're going to have a high tide on this side when the moon is here, okay? Okay. And then when it's farther away, we're going to have a low tide, okay? Now, what about the sun? Do you think the sun has any effect on this making the Earth not perfectly round? The gravitational pull of the sun on the earth is 180 times stronger than the pull of the moon on the earth. Okay, I'll say that one more time. The pull of the sun on the earth, the gravitational pull, is 180 times greater or stronger than the pull of the moon on the earth. And yet the moon affects our tides more than the sun. Why is that? Anybody have any thoughts?
Is it because the distance is closer to the moon?
Very, very close. You're on the right path. Do you remember what I said?
Is it because
What were you going to say, Becca?
I was gonna say, is it because like the moon goes around the earth more times than the earth goes around the sun, so like pulls it back and forth faster?
No, not exactly, because the earth, with the earth spinning, that's kind of like the sun going around the earth, right? At least that's what they used to think. So that part is the same, but
Yeah.
put it into this perspective here. Here's the earth, let's say, and here's the sun. Okay. If we look at the distance between the sun and the earth here, what's the difference between this side of the earth and this side of the earth? Almost nothing, right? The distance from the sun all the way to this side of the earth facing it, and the distance from the sun to the opposite side of the earth, basically the same, because this distance is so great between the earth and the sun, it doesn't really affect the tides a whole lot. It affects them a little bit, okay, but not much. Okay. Does that make sense? Let me clarify it a little bit more. Do we have tides in ponds, lakes? Does the water in a pond or a lake move with the moon? No, because your little pond, distance from this side of the lake to the moon and the distance from this side of the lake to the moon are basically the same. Okay. And so there isn't a big enough change in the gravitational force to cause the ocean or that water to move. Okay. But again, if I draw this picture with the moon over here now, if this is the moon, sorry, bad picture, and this is the earth, this distance right here is significantly different than that distance. And that's why the moon has a bigger impact on moving our water than anything else. Okay, the sun's just too far away, and ponds and lakes are just too small. Okay, so keep in mind when they ask you on homeworks or tests or whatever that the thing is that it's the difference in the distance between the moon and the earth that causes the tides. Okay, all right. A couple of other definition things. Let's talk about spring tides. Here's the first bad news about spring tides. They have nothing to do with the spring as far as a season. Okay. These are higher than average tides. And they happen when the sun and the earth and the moon are all aligned. Okay. So these are higher than usual, higher tides and lower than usual low tides. Okay. So when is the Earth, the Sun, and the Moon? What time of the month would the Earth, the Sun, and the Moon be exactly or most closely aligned? I'm going to put the Earth here. When would we have higher than average tides if they all have to be aligned? Well, the Sun would be over here, obviously not drawn to scale. The Moon would have to be pretty close to that axis. Okay. Now the sun is a lot larger than this. I'm going to erase that for a second. Okay. And stop drawing on my board. Right, the sun is like this. So the rays of the sun are still going to hit the moon. Okay. And when they're aligned like this, we actually get a full moon. So if you have ever paid attention to tide charts, if you live near the ocean, they always publish tide charts in the newspaper. You'll always find that the highest tides happen when there's going to be a full moon, or what do we call that? Because it's going to be dark on this side of the moon to us. Call that a new moon. Okay. So when we have a full moon or we have a new moon, we have a spring tide. So if you think about a 30-day month, right? Twice during that month, you're going to have a full moon, and I'm sorry, once you're going to have a full moon, once you're going to have a new moon, and everything in between there, the tides will be affected, normally. Now, when the moon is here, okay, or on the opposite side, okay, now we're going to have just average high tides. Okay. Now, when would we have, oh, sorry, before I move on from that, these are called neap tides. N-E-A-P. Okay, so we get less fluctuation in the tide when the moon is kind of 90 degrees offset from the moon. I mean, from the sun. When the moon is 90 degrees offset from the sun. Okay, so those are neap tides. Now, when do we get the highest tides ever? Anybody know? Right. If this is perfect in perfect alignment, and we get a lunar eclipse, that's when we're going to have the highest spring tide, or if we have a solar eclipse over here, that's going to be another time where we're going to have the highest spring tide. Okay. So if you ever in your future, start to surf or just want to know about the tides a little bit more, you can always look at the moon, and that will help tell you how high or how low the tides will be. It won't tell you the times necessarily, but it will tell you whether it be a much bigger high tide or not. If you know there's going to be a full moon out, okay, the tides are going to be coming in, and it's going to be coming in pretty high. Okay, so kind of some good, that's actually kind of a little life component to take away from this. Okay, all right. Now, as I said before, tides, this discussion of tides, this is pretty simplified, okay? But just kind of some kind of some fun, one fun fact. Because remember, we said that the average high tide is only 1 meter above normal. Okay. But there's some places in the world where you get tides that are sometimes as big as 15 meters above normal. Okay. There is a bay, it's called the Bay of Fundy. Not even kidding. It's up between New Brunswick and Nova Scotia on the eastern side of Canada. And the problem is that coming into the beach, the ocean floor makes a V, and the water just ends up rushing through that V, and they get huge waves on the shores of the Bay of Fundy. So, and not only that, it comes in so fast, it comes in over 25 miles per hour. So you don't want to be standing near the edge when that starts coming in, because you cannot outrun it. Okay. Not even you, Addie. So that was just a little fun fact about tides. Okay. So as I warned you yesterday, kind of some interesting stuff, and I want to open it up now to questions about this lesson. Yes, Becca.
The one part, like earlier when you were saying like Europe and the United States, one is high tide, one is low tide, is that like, well, I guess they're not on opposite ends of the earth. Is it because like Europe, if it was closest to the moon, the United States would be like halfway to the other side?
Yeah. It'd be like, this is probably a little better demonstration. It'd be like Europe being over here and the United States being over here. And so if the moon was over here, the Atlantic Ocean tides would be pulled in that direction.
Okay.
That kind of make more sense.
Yeah. So the ocean would be pulled the other way on the other side of the US then?
You're right, because here's the other part of the U.S., right? And so on the Pacific Ocean, if this is the Atlantic Ocean, the Pacific Ocean we would be pulling in that direction. So it actually would have a tide on both sides of the United States if it was aligned just at this exact, like as the Earth is spinning. I don't know exactly where the moon is going to be, but if it happened to be where the United States was right in the middle like this, it would have low tides on both sides of itself, because the oceans are going to be pulled in those two directions at the same time.
Okay. Could like one ocean, like could the Atlantic Ocean be like pulled like apart kind of? Like
No.
if the Atlantic Ocean was centered in the middle, then would like the pole be like pulling high tides on the US and Europe?
Definitely.
Yes?
Yes.
Would that like
Can you hear
tear
me?
the ocean?
I'm having bad internet issues here at my house, so. Oh, you know what? I forgot one thing to mention because we're talking about this now, but let's take a look. If the United States was here, kind of in the middle, if you think about it, our Earth is not solid. Our Earth is actually molten iron. Most of it is molten and plasticky, and it moves a lot, and it's got this thin, hard crust on the outside. So the Earth, the actual physical Earth, actually moves a little bit too. And at its strongest, if the moon was over here, the actual physical crust of the Earth can move as much as 1/4 of a meter at its highest, which, doesn't sound like 25 centimeters is not a ton, but if you think about the Earth, the crust of the Earth moving that much, that's kind of crazy. This is one of the reasons why we see earthquakes, is because that crust is being moved as the Earth is rotating and the moon is rotating with it. That crust is being pulled in different directions 4 times during the day. And that's why, again, why we see so many volcanoes and earthquakes on edges of continents, because that's where the crust is going to be the weakest. So the crust of the earth is also being moved. The atmosphere is being moved also. We don't feel it down here on Earth because we're kind of at the bottom of the air ocean, but it does, the air up above in our higher parts of our atmosphere do move as well with the now, one thing that I should point out, I hope this is obvious, right? The moon is oblong shaped also because of the pull of the earth on it. Okay, so don't worry about that. Okay, all right, Paige.
I was just thinking about this because of the atmosphere and because I was just in NASA a couple weeks ago. But like, if they're launching things into space, do they wait until the atmosphere would be like the thinnest part, kind of like the low tide of the atmosphere, I guess, so that they don't have to go through as much?
That's a very good question that I do not know the answer to. That I will have to. I don't know if the held, has to worry. But definitely, obviously, there's the faster that rocket ship goes, we learned in our other chapters, the more friction there is, and so that might be a very, very wait until there's quote unquote low tide in the atmosphere and then launch at that time. That could very well. Anybody else have a question on this? Michelle's asking, does the moon travel in a straight path around the earth? No. It definitely fluctuates its path, and it travels what's the right word? Elliptically. So it does not travel like if this was the earth right here, it does not always travel in that line as it comes back around. It will be this the next time and then like this the next time. So it is not the same path all the time. Good question. One other fun fact about the moon is always facing it. When you look up at the sky at the moon at night, it's always the same face of the moon facing you. The moon rotates, but it doesn't rotate fast enough to ever change its face towards us. Okay, so it will always be, you'll always see, that's why we always see the man in the moon, quote unquote. Okay. Okay, any other questions about today's assignment or today's lesson? All right, Paige.
Wait, so if the moon was rotating, or like it is rotating, do you ever see different parts of it? That doesn't make sense. Like, how could, like, would different parts of the world see the different parts of the moon? Or like,
So what you see, what we see in the States is fairly the same, but what they see in China, for example, is going to be a different face of the moon. Because basically what is happening is the moon is rotating about the same speed as a month. It basically takes a month to rotate, and that's where we see the different phases of that's a different phase. That's one complete phase of the moon, and so it just comes back around to the same phase every time. Part of the moon is blackened out, and so that as it's rotating around, and so that part will always be the part that's blacked out to us. Now, I shouldn't say that. It's a little bit different every time because it's like the rotation of the moon is like 28.7 days. It's not exactly 30, but that's what we base our lunar calendar off of, right? Is off a 30-day moon rotation. Any other questions about that? All right. So I will send you the questions that I want you to work on for this weekend. And we will continue to work at 2:00 until further notice. Okay. All right. If there are no questions, thank you guys. You guys can check out anytime you want at this point, and we will answer questions.